Okay, we've got two spheres colliding, A and B. B has got a mass 2m, A has got a mass of 3m, and they're colliding offset against each other. Okay, now clearly it's important we find out the angle of collision. So we know the distance between the two centres is 2r. We're told this is 1.6r, and if we use Pythagoras, should we need it, we can get this is a 453, so it's 1.2r. So we can find that angle now. Okay, alpha. So we've got, whichever way we want to do it, sine alpha equals 1.6 over 2. So we've got alpha in effect. Okay, and if we need cos alpha, is going to be 1.2 over 2. That's 3/5, and that's 4/5. Okay, so we've got those in our locker. Alright, so they're going to collide, and we know the direction. That's the line joining the two centres when they collide. So we've got this one coming in. I'll move it down here just for convenience. 2u. So it's got two components. The one that's going directly into the wall, into the not into the wall, but perpendicular to the line of collision, and then we've got one here which is directly in the line of collision. We've got alpha here, therefore this one is alpha, corresponding angles. This is 2u cos alpha, and this is 2u sine alpha. We do a similar thing for the one at the top here. So this comes in with u. And again, it's got two components, that direction and that direction. And they are, we've got to find the angle alpha, obviously first. Alpha's here. Alpha will be up here. This would be alpha, wouldn't it? So this is u sine alpha. Space here. See why I need a big diagram. U sine alpha, and this one's u cos alpha. Okay, so that's all the information we need on the diagram. Right, now we just got to think about what happens afterwards. So after they've collided, I'll draw one afterwards. So we've got A and B. We know in the direction perpendicular to the centres, so this direction here, this direction, that the velocities are unchanged. So we know that A will carry on u sine alpha in that direction, and we know B will carry on with 2u sine alpha in that direction, unchanged. What does change is so we'll put A going that way and B going this way. Okay, I'm guessing they're going to bounce off each other. If I put these in the wrong direction, it'll come up with a negative sign, so that will be fine. Okay, so we're now going to apply the conservation of linear momentum. We're only going to do it in that direction because there's no change of momentum perpendicular to that. So we've got, this has got mass of 3m, so 3m u cos alpha, mass times velocity. So I'm taking down that way as positive. Okay, so down is positive. Take away 2m times 2u cos alpha. So it's 4m u cos alpha equals the momentum afterwards. Remember, I'm taking this way as positive, so it's 2mb and then minus 3ma. Okay, so that simplifies. The m's will cancel, and that gives us minus u cos alpha equals 2b minus 3a. I know cos alpha from earlier, so cos alpha is 3/5, remember. So times it all by 5, I get minus 3u is 10b minus 15a. And then I'm just going to switch that to make the u positive. No particular reason, but 3u is 15a minus 10b. I just prefer this to be positive. Okay, we're now going to use the impact law. So the speed of separation, and these are in opposite directions, so the speed of separation is a plus b equals e times the speed of approach. The speed of approach, these are in opposite directions, so it's 2u cos alpha plus u cos alpha, it's 3u cos alpha. Okay, again, I know e is a sixth in this case, so it's 3/6 u times cos alpha, which is 3/5. Okay, and this equals 9/30, which is 3u over 10. Times everything by 10, I get 3u equals a plus b. Okay, so I've got a pair of simultaneous equations now, 1 and 2. Right, so moving over the page. So I've got, let's write them down again, 3u equals 15a minus 10b, and I've got 3u equals 10a plus 10b. So if I just add these together, I get 6u is 25a. So a is 6u over 25, which is 0.24u. Similarly, I find b by using one of these, doesn't matter which one I use, so b is 0.06u. The fact they're both positive means the direction I picked on my diagram is in fact the correct direction. Right, now I've got to find the magnitude of the impulse received by B. So the impulse is mass times change in velocity. The mass is 2m. The velocity initially is 2u cos alpha. And then afterwards is, I've got my diagram now. Okay, afterwards is 2u cos alpha. Sorry, before it's 2u cos alpha, afterwards it's minus b in the other direction. So I'm going to take away minus b, so I'm going to add a b. So that equals 2m times 2u times 3/5, which is 6u over 5. B we know is 0.06u, and then we get 2mu times 1.26, which equals 2.52 mu is the required impulse.